we are going to brush up today is about basics of some object-oriented concepts in core Java. Okay, so I'm directly going to jump to the basics of object-oriented programming, where I'm not going to explain you very basic things of any programming. Is just I'm assuming that you know basics like what is variable, what is method, what is class, and stuff. So we are not going to discuss all those things, and we are going to see that. So if you are going to program in core Java, or you're going to program on some languages or on some frameworks which uses core Java, these are going to be some very basic concepts. And you can say that whatever we say or whatever we do in this particular session, it holds true when you're using core Java in any condition. Okay, so let's start with some basic concept, what we call it as object oriented programming. Okay, so basically Java is a language, right? So I can say it's a language like your English or German or any language, right? So but it's not the language that we speak. But when we speak or we talk about any language, there has to be a grammar related to that language, right? So we can say that what are we going to learn today are is kind of a grammar of that language. It's like a pillar of that language. So if you have a good hold on these things, then you can uh, you know uh, um, you will not face any basics issues when you are uh, learning or doing some programming with Java. I've seen people that they get stuck when at very basic level of concepts as well. So let's see that how much we can brush up this concept. Is I'm not going saying that I'm going to teach you this from scratch, but I'm saying that we are going to brush up these concepts. Okay, so when we say object oriented programming, we have abstraction, we have inheritance, we have polymorphism, and what else? We have encapsulation, right? So let's start with abstraction. We will start talking about every concept, and while talking about one concept, I mean, we will be talking about another concept as well, but we will try to understand that how we got into another concept from the first concept. So let's start with here. First concept, which is your abstraction. Okay, so how do we use word abstract? Leave about your language, just if you want to say how do we uh, use word abstract as a word in English language. So for example, that many people, when they say submit a project thesis for their graduation, they said, okay, we first have to submit our abstract, because that's where we give a very high level information of something that we are going to do, right? So you can say abstraction even Java is also, you can say, is something that you are defining at a very high level. Okay, and you're trying to generalize something. So there are certain benefits of abstraction. So let's start with certain example. Okay, for example, you have something called as a car. Okay, now when I say car, I can always say that okay, car has wheels, car has a steering, car has a body, car has a color, right? And whenever I'm talking about any car, I can always generalize that okay, every car has all these features, right? Say now I'm talking about some particular brand, say X. Okay, now when I'm talking about particular brand and I'm talking about say particular model, then I'm maybe probably I'm talking about very specific things. Now imagine that you want to develop an application which is for say automobile industry. Okay, so say you have company X and model M. Okay, now in this case, what you are going to do is that say you want to write a class which is about say model so and so. So let's say you're developing for say Lamborghini. Okay, and you're writing a class, say my public class Lamborghini. Okay, now is it a good idea that you're writing a class Lamborghini and you start writing that class from scratch? Okay, Lamborghini has wheels, Lamborghini has a color, Lamborghini has a door, Lamborghini has engine. I mean, how does it make sense that okay, these are properties for every damn car, right? Why are you writing all these generalized things for your Lamborghini, right? That means we have to generalize this something. So I can say, okay, I want to say that I have a class car and I can have all these common properties which every car is going to possess, right? And whenever I said, okay, I want to talk about Lamborghini, maybe I can just say that, okay, Lamborghini is going to use class car where I have defined all these generalized properties, right? So I can say I have a class car which is is a general definition of every car. Okay, so that's what. So what I did is, okay, I created some sample class car. I have wheels, color, brand, blah blah blah. Okay, and if you see here, so what I did is I specified this class as an abstract class. Okay, now is that the only purpose of creating an abstract class? Okay, whatever I want to make it generalized properties, I have put in abstract class. No, now imagine, or there is a property of your abstract class that when you say you have an abstract class, you cannot create its object. Now let's um, assume that you can create an object of your abstract class. Let's try to understand that why can't we create an object of abstract class. Okay, so as we consider example of automobiles and particularly a class car, let's say that uh, you have a car, or you are walking on the road and you see a car. Now is it possible that whatever you are seeing is just a car? There is no brand associated with that, there is no model associated with that, it's just a car. No, it cannot happen that, right? I mean, uh, so when you're saying that there is a car, there will be a some brand associated with that, there is some specific model associated with that, right? So you say that, okay, this is a car of so and so company and this is so and so model, and you cannot say that, okay, this is car. No, there is no company associated with it, there is no, you know, there is no model associated with it. Okay, so that's the thing. I mean, when you say you have a car and if say you are allowed to create a new object of it, so it's like you are saying that bas- there is a physical car present which has no brand or, you know, no particular model associated with it, right? So that's never going to happen. So, or consider that you have a class called as an employee. So I say that, okay, I'm employee of say company X. Okay, so someone comes to you and asks, okay, so for which company do you work? I say, okay, I work for say X company. So okay, what do you do there? No, I'm an employee. No, but do you have any designation? No, I'm just an employee. Is it possible? I mean, if you are working for a company, maybe you are a manager, you are a programmer, or you are a sweeper or something, but you have some particular designation, right? You cannot say that I'm just employee, right? So if you say that employee is a class and you can say that employee is equal to new employee, then it doesn't really make any sense unless you say that, okay, you are so and so. I mean, you hold particular designation, or you hold particular position in that particular company. You are a CEO, you are a programmer, you are a manager, or whatever, right? So that's the thing. So this is what your abstraction is on with at another level. I mean, first thing what we saw is we are trying to generalize and keep some particular things in your abstract class. Second thing what we are trying to do is, um, even though you have a constructor there, you are not allowed to create an object of your abstract class. Okay, second thing is, say when I'm talking about abstraction, okay, I want to highlight certain things. Okay, so say I'm talking about abstraction, and say here I have this particular employee class. I have defined particular parameters, or say fields, your name, designation, salary, and I have employee ID, count, so and so. And what I have done is I have exposed those variables. We'll come to that anyway when we come to encapsulation and other things. But yeah, so I have some particular fields, and I'm exposing them with through some different mechanisms. Okay, now consider that I have a class called as a manager. Okay, so now again I'm talking about a manager. So managers are going to be people who are also going to be some employees, right? So you say that okay, I'm a manager in so and so company. Okay, now again the question is what kind of manager you are. Are you project manager, or you're product manager, you're HR manager, or I don't know, I mean, whatever. So but when you say that okay, you are a manager, that you have certain responsibilities, right? So you can say that when I'm trying to create a class called as a manager, I can still say that okay, my class is an manager class is an abstract class. Okay, and my abstract class is extending an another abstract class, which is my employee class. So what I'm saying is whatever is there in employee, everything is there with my manager class, and I have some certain extra properties and functionalities with my manager class. Okay, another thing is when you say you cannot create an object of your abstract class, that means that how are you going to use your so the question is how are you going to use your abstract class. That means there has to be a certain another class which is making use of your abstract class, so that whatever you have declared as a common properties, or you're trying to generalize something, okay, so you should be able to make use of it, right? So every time we want to use an abstract class, we say that okay, a certain class or a child class is going to extend your abstract class, and this is how you will be able to your make use of your abstract class. Okay, so we are going to discuss about extending any class in details when we are going to talk about your inheritance, but we are not yet done with concept of our abstraction. Okay, so if I go to my employee class, I see that okay, I have certain method called as say get salary, and I see that even my get salary method has an abstract keyword. Okay, if I go to my manager class, it's an abstract class, and I have a method say add team member, and again I have a keyword called as abstract. Okay, I go to a class car, and I see a method called as a drive, and I see a keyword called as abstract. And if you observe these methods particularly, you would see that okay, these methods are a bit different. They don't have a body. I'm putting semicolon after my methods definition, right? So what is basically an abstract method, or why do we need abstract method? So what are we trying to do here is that we say that okay, I have a car, and obviously if there is a car, it can be driven. Okay, or if I have there is an employee, obviously that employee would get some salary, he's not doing some charity work, right? So but you don't know that how much salary that employee is withdrawing, or you don't know that how that car is being driven, or there is an process of adding a team member to the for a manager to a particular team. So there could be some different processes in different companies, right? So basically what we trying to do is imagine that you're trying to define a certain class, okay, and you are sure that there is some particular property that every class, or every class which is going to use that particular class, uh, like let's talk about more elaborate example. Say again we are developing an application for automobile, and suppose I'm there are two programmers. One is say developing for say BMW, another is say developing for say Audi. And yeah, so there is a class called as a BMW, there is a class called as a Audi, and I'm saying that okay, class BMW extends car, class Audi extends car, right? So now there are some common properties which both BMW and Audi are using: wheels, their it has a body and stuff, right? So now there comes a situation that okay, I want to mention that, or both programmers needs to write a code that how that car will be driven. Okay, now the problem is that the application is going to be huge. It's not just about BMW and Audi. It's going to be about say some hundreds of different companies and thousands of different models, right? Imagine that there is a huge team of programmers who are working on that project, and everyone is developing a separate class for every model depending on specialities of that model. Okay, and everyone start using their own conventions while writing methods and properties and stuff. So you see that there is no consistency across the app, and the app is that whatever that application is, that is completely screwed up, because The moment one programmer starts working on another class developed by another program, he cannot understand anything because his terminology, his naming convention of methods is totally different, right? So now how do you tackle this particular problem? Okay, so already we are trying to make sure that by using class car as an abstract class, we are trying to reduce our efforts. We are trying to reduce uh, the time that we are taking for developing a single class for every model, because we have separated out our properties at common place called as a car. Now what I want is to maintain a consistency. So what I will do is I will just say there is a method which is say add team member, or there is a method called as a say drive. Okay, and these methods are say abstract methods. So when I say this is an abstract method, so again I'm saying that okay, I'm just defining at very high level. I don't know that how every model of that particular automobile is going to handle that, or how that every manager is going to add a certain new member to a team. But yeah, there has to be a process for achieving these particular things. Okay, so now when I say that, so what I'm trying to do is I'm forcing or I'm compelling all other classes which are going to extend classes like car or employee or manager, that once I mention a certain method as an abstract method in all these classes, then whichever class will try to extend my employee class or manager class or class car, they will be forced to have an implementation of that particular abstract method. Okay, so we say that there is an abstract class and there is a concrete class. Concrete is not a keyword, but I can say okay, a class which is, if I create an object of that particular class, and so that means that's not an abstract class, and say that class is extending an abstract class, right? So that means if I have a say class called as a say Lambo, which is say I'm trying to say there is a car called as a Lambo and which extends car, then what I'm trying to say is if there is any abstract method in class car, then class Lambo will be forced to have its implementation. Okay, so if you see that drive was an abstract method in my class car, so now Java will force your class Lambo to have its implementation inside a Lambo class, because Lambo is not abstract class. Okay, so I'm again repeating, Lambo is not abstract class. So class manager, unlike Lambo, which is an abstract class, so whatever method I have put inside employee class, see if I go to employee class, you see a get salary method which is abstract. But do you see implementation of get salary method inside manager? No. Why? Because manager is also abstract class. It's not a concrete class, right? So manager class won't be forced by Java to have implementation of my get salary method. Okay, so now whichever class will try to extend my manager class and say that manager is say HR manager. Okay, so I have a HR manager which extends manager, and manager extends employee. So whatever abstract methods are there in my employee class, or whatever abstract methods are there in my uh, um manager class, all will be forced to have its their own implementation in my HR manager class. So if you see here, I have a get salary method, I have a give report method, I have a add team member method, and some of these methods you can see are abstract methods in my manager class or my employee class, right? So if you see, I have a get salary, I have add team member, which were abstract methods, and when I go to HR manager class, I can see that I have a add team member and I have a get salary method. Okay, so basically let's revise, or let's summarize what your abstraction is. So, and what are the advantages of your abstraction? So first thing is, by declaring certain class as an abstract class, or saying having abstraction in your application, first thing what you're trying to do is reduce the number of lines of code you are going to write for each and every class. So you're trying to reduce your efforts, you're trying to reduce the development time. Okay, and you're trying to maintain the consistency because all these common properties are mentioned at one place. Okay, again you're trying to maintain the consistency by declaring abstract method. So if I say that my class car has a method called as a drive, which is an abstract method, so all the classes which are going to extend class car will be forced to have a drive method. And eventually what would happen in this case is that you will see there is a consistency. So say any programmer goes to any class, car class, and as in a particular class which is extending a class car, then he would observe that okay, there is a drive method, so he doesn't have to search for a functionality drive. Okay, where is my drive functionality in this particular class, right? Because he knows that every class is extending car, so there has to be a drive method in every class, right? So these are the things which we are trying to achieve when we are saying that we have trying to use the abstract class. So whenever you're using abstract class, try to understand that why do you need abstract class. Or whenever you're trying to create a new application and you're trying to create its architecture, its design, think that are there any common things I can put it in a common place and I can have multiple layer of abstraction in my application. Okay, so this was about abstraction. And while talking about abstraction, I kept saying that okay, you have one class which is extending another class, right? My HR manager extends manager, manager extends employee, right? So when we are basically talking about one class extending another class, so basically we are already talking about inheritance. Okay, so how do you say there is an inheritance in general? So you talk about a parent child relationship, right? A certain things which uh, parents have, and you say that okay, those things are inherited to a child. Okay, so certain, let's talk about inheritance in Java, and what are the limitation, what are the advantages. Okay, so first thing is that consider your example that there is a father, there is a mother, and there is a child. So you say that okay, child has got some properties from father, child has got some properties from mother, right? You say that okay, child has hair like his father, and maybe you say eyes like mother, and so, right? But when you're writing a class in Java, you cannot say that okay, class child extends father comma mother. That means Java does not support multiple inheritance. Okay, so you cannot extend more than one class. Okay, so let's understand that why Java doesn't allow you to have multiple inheritance. So you can say that earlier you had only C and C++, and C++ was introduced as object-oriented language, though it was not fully object-oriented because you could still write program without classes. Yeah, but when it came to Java, that Java became your kind of first language which was completely object oriented. And so uh, now if you consider that you have a class child and you say that okay, class child extends father comma mother, suppose this thing is allowed in Java, that is your multiple inheritance is allowed in Java. Okay, now consider that class father has a method called as a work. Okay, and class mother also has method called as a work. Okay, so that means both the classes have a method called as a work, and because of some concept of abstraction or something, that work method has been for or work method was forced to have implementation in class father and mother. Okay, now consider that father is a doctor and say mother is a lawyer. So that means whatever you are going to write inside a work method, inside a father class and inside a mother class is going to be different, right? Now, if you say class child is allowed to have multiple inheritance, and you say that class child extends father comma mother, and imagine that when we talk about say parent child relationship, or what we say is according to inheritance, when we say that you have a class A which extends B, then whatever is there in the B, everything will be available in say class A, provided it's I mean, I'm not talking about access specifiers right now, but for time being, assume that whatever is there in your parent class is say available to your child class, right? So what is going to happen now? So you have a class child, inside class child, suppose you don't have any method called as a say work. Okay, and what I do is I just say that okay, child C is equal to new child. Okay, now according to concept of inheritance, whatever method is there in your parent class is accessible in child class. So I'm saying that c dot work. So I'm trying to call a method called as a work on object c, which is of class child. Okay, now there is a ambiguity, there is a problem, because you said that multiple inheritance is allowed and class child extends father and mother both the classes, right? And there is a work method in your father class as well, and there is a work method in your mother class as well, right? So now what is going to happen? So you she doesn't know that, okay, which work to use. There is a work from father also and there is a work from mother also. More than that, there is a bigger problem. The child is not doctor and child is not, he's not lawyer as well, right? So I mean, why are we forcing class child to do such things? So this is something that we don't want to get into, as we are using inheritance in Java. So what Java did is it has introduced a concept of interfaces. Okay, so we'll talk about interfaces more, but yeah, so basically inheritance is extending a class. Okay, but you can extend only one class at a time, so multiple inheritance is not allowed. So according to inheritance, whatever is there in your parent class, so this becomes your parent class, this becomes your child class. So whatever is there in your parent class will be available in your child class. Okay, I'm not yet talking about access specifier, so we will see in what all scenarios there will be limitations when I say that whatever is available in parent class will be available in child class. So for time being, assume that whatever is there in parent class will be available in a child class. Okay, we will see limitations later on. Okay, so for example, if I go to this programmer package and if I see there is a Java programmer class, right? So if you see, have I declared name as a variable anywhere? No, but what I have done is Java programmer extends employee. So if I go to employee, I see there is a variable name and I'm able to access that variable inside my Java programmer class, and I'm trying to assign some value to that particular variable name. So basically inheritance is what we call is a relationship, and we are trying to pass, or we are trying to use whatever we have declared inside employee class inside my Java programmer class. So I'm trying to combine your concept of abstraction and inheritance together. Okay, there is more to your inheritance, but let's come to that point slowly. Okay, now when we talk about inheritance, so we just spoke about abstraction, and we said that okay, if there is a get salary method which was an abstract method, and so Java programmer was forced to have get salary implementation here. Okay, but it's quite possible that there are some non-abstract methods, right, in my parent class. Like in this case, I have a method called as open door, right? Or in case of my employee class, I have some methods like set name, get designation, set designation, and these are not abstract methods, right? Similarly, I go to manager class and I have a method called as evaluate team member. Okay, or I have a method called as a give report, and these methods are again not abstract methods. Okay, so by the concept of inheritance, okay, so you are allowed to even override, or what we say is uh, have a separate copy of that existing method inside your uh, child class. So if you see, uh, if I don't have this give report method here, say I'm removing this give report method here, and but I want to use the give report method here, so I can always say that okay, give report, right? So give report method is anyway available, even though it's not part of my HR manager class. It's there in my manager class, but it's available because it's a concept of inheritance, that whatever is in my parent class, I can use it in my child class. Okay, and we are going to talk about this override more, that okay, whenever we are trying to have the same method from my parent class to a child class, we are trying to override it, but we'll talk about it later. So yeah, so again, summarizing your inheritance, basically inheritance is about your child parent relationship. Java doesn't support multiple inheritance, you can extend only one class at a time. Okay, so as far as we are not talking about access specifier, whatever is there in your parent class is available in your child class as well. Okay, and so now we want to solve the problem of your multiple inheritance. Okay, so let's go back to your example of automobiles. Okay, so suppose I am saying that I have a class car. Okay, and so when I'm saying that class car, I'm expecting that it's going to be my abstract class. Okay, so now in this my abstract class, what's happening is that um, when I'm developing this huge automobile application, there are certain cars which can take part in say racing. Okay, and the way every car can take part in race, or the way it use its capabilities in racing, are different. Okay, now imagine that if, considering that race is going to be a common method in all such classes which can take part in racing, if I put this method called as a race, okay, inside my abstract class car, what is going to happen? Now imagine there are some cars which say, there are small cars which not designed for racing. These are just small cars you are supposed to drive in a city for small distance and local commutes, right? Now when you are saying you have such particular model, and you want to say that, okay, my uh, this particular class or this particular model also has a race functionality, so that's ridiculous. I mean, how can you design your application in a way that, okay, all class or all cars in your application can take part in racing? Okay, just because you wanted that as a consistency or a common functionality among few cars, right? So basically, when we are talking about inheritance, I can talk about two basic things. One is your property, and second is your functionality. So I can, when I'm talking about inheritance, so I'm talking about father child. So I can say that, okay, child has hair like his father, or his eyes are like his mother. But it's not appropriate to say that child is going to work like his father, or going to work like his mother, right? So that's not a correct way, because I'm talking about functionality. Child may be a, maybe an engineer, child is not doctor, child is not lawyer. Okay, but when I'm talking about, okay, child has two eyes, one nose, and his complexion and stuff, which is matching with his parents. So I'm basically talking about child's properties. Okay, I'm not about talking about what child does, right? I'm not talking child is going to sleep all the day, child is 1 year baby. You cannot say that, okay, what the kind of work father is doing or mother is doing is you can expect from the child as well, right? So yeah, so now, as we have basically distinguished between these two things, that, okay, inheriting the properties and inheriting functionality. So we don't say that, okay, functionalities are going to be inherited. So instead of that, we talk about interfaces. So what I do is, I have a concept of interface, and I say, okay, I have an interface called as, say, racing. Okay, and inside racing interface, I have a method called as a race, and I have a method called as a, say, power boost. Okay, now if you observe this interface, first of all, there is no keyword called as a class. Okay, second thing is, these methods race and power boost, they look like they are abstract methods, but am I using keyword abstract? No, I'm not using keyword abstract. Then how am I or how is it possible that I am writing a method without abstract keyword, and I'm directly putting a semicolon, I'm not specifying the body? So basically, as I mentioned here, so when we are talking about interface are 100% abstract. That means if you go to your class car, which is an abstract class, right, you can see there are methods which are not abstract, right? That means this particular class is not 100% abstract. Okay, in fact classes are, I mean, they are not supposed to be 100% abstract, or it's not necessary that they will be 100% abstract. Okay, but when it comes to your interfaces, they are 100% abstract. And if you see these are the two methods which I have defined, and uh, these are not, I have not specified abstract, but these are by default abstract. So even if I write keyword abstract, it's not going to give me any error, but that's redundant. Also, if you see, I have not specified any access specifier like public. So by default methods in your interfaces are public, and you write it public or you do not write them as public, okay, it doesn't matter, it would be redundant. Okay, and every variable we declare inside your interface is by default constant. So what is constant in Java? You can say it's just on a broader level. By default it's static and it's final. Okay, you can say that okay, only final is sufficient for constant. But yeah, when I'm saying that okay, I want to use this particular variable outside my racing interface, and I want to treat it as constant, then I can say I could have written it like public static final, but it's not really necessary, because whatever variable you declare inside your particular interface is by default public static final. That means it is a constant. Okay, so you cannot change the values of variables that you declare inside your interface. Okay, so yeah, so now let's see that how do we make use of this interface. So as I said that okay, I have a, there are certain classes, or there are certain cars, okay, which can take part in racing, and I want to maintain a consistency that okay, tomorrow if I go to any class and I see that this particular car or this particular model can take part in racing, so I should find a particular method that okay, this is the method inside which I will find a functionality related to my racing, right? So what we do is, suppose you have this particular class called as a Lambo which extends car. So whatever are the properties which will be inherited to your class Lambo, but the moment we start talking about a functionality, I'm saying that okay, this class or this car can take part in racing. So I say my class is implementing an interface racing. So the moment you say your class is implementing a racing, see, your id is smart, and what it has done, it has highlighted the methods which are, you know, forced, or which were forced to implement inside your class Lambo, because those were abstract methods, they didn't have body. But as Lambo is a concrete class, it is implementing an interface, it can have a proper implementation of those methods. So now race and power boost, which were abstract methods, we are forced to implement those methods inside your Lambo class, and we will have some body inside these methods. Okay, now if a programmer forgets to write inside something inside this method, then it's programmer's fault, right? But at least you would see that okay, there is a method present with name race and power post. Now imagine that you have total say 1,000 classes in your automobile application, and out of these say 1,000 classes, there are only 10 classes representing 10 different models which can take part in racing. Now imagine 6 months down the line, you got new requirement where you say that okay, now all the cars which can take part in racing should also have this extra functionality X. So now imagine 6 months down the line, whoever had developed this entire application is not working with the company, he has left the company, or you have no idea about what the code is, and now your challenge is to find all these 10 classes. So do one thing, go to your racing interface and just say that okay, I have a new functionality called as X, and I want to add that functionality X here. So I say okay, I don't care that who is implementing this. I just say that if this racing interface or whoever is taking part in this racing, for them I'm going to have an extra functionality X. Okay, now you're trying to compile or run the program. What is going to happen is, the moment you declared an additional method inside your racing interface, see, your Lambo started giving an error saying that okay, there is an additional method in your racing interface and that is not implemented in your this particular class. So we are taking care that by adding a new functionality or modifying a functionality in your interface, okay, you are trying to make an effect on your entire application, saying that okay, now all these 10 classes who were implementing all racing interface will, start uh, giving you error, saying that okay, we are the people who can take part in the racing, and you said that we need to have a additional functionality but we don't have it, so let's implement that additional functionality in this particular class. Okay, so this is how your interface helps you in maintaining the consistency, which again I can say that which we were achieving using your abstraction. But when we want to talk about a difference between your abstract class and interface, I can say that racing is an interface as in it's 100% abstract, whereas my class car is not interface, it's an abstract class, and it's not 100% abstract because it has non-abstract methods. Okay, second thing, your difference between your interface and your abstract class is you extend in your abstract class but you implement the interface. Okay, that's literally a stupid uh, difference, but yeah, I can say that you extend your class by but you implement the interface. Now important thing about your interface is you are allowed to extend only one class but you can implement as many as possible interfaces. For example, I can say there is a person, okay, he's an employee, but I can say he's an employee when he goes to or he goes for work and he's in office. Okay, now he comes back from office and he goes to the cricket ground and he's playing the cricket. So I can say that now okay, now he's a cricketer. Now he goes to club and he's playing a table tennis, and I can say he's now table tennis player. Okay, now he goes for swimming, so I can say now he's a swimmer. So I can say that there is an interface called as a, a cricketer, a swimmer. I have an interface called as a table tennis player. Okay, and all the common properties of, or I can say there is an interface called as a player. Okay, and all the kind of common functionalities which every player would possess, I'm just putting all those methods as an abstract methods in that particular interface, right? So depending on if that player is a cricketer, a swimmer, or he's a table tennis player, whatever it is, okay, I can say that okay, a same person can perform different roles in different situations, right? So that's the beauty of your interfaces. So you can say that you can extend only one class but you can implement multiple interfaces, and that's how you are trying to solve the problem of your multiple inheritance. So I can say that that particular mother and father, they are implementing an interface called as say workable. Okay, and my say interface name is workable and it has a abstract method called as a work. Okay, now my father is implementing workable interface, my mother is implementing workable interface, and so my father and mother has class has work method, and then they have defined different work. And at the same time I have a child class, and if child class, if it is uh, it's eligible for implementing that particular interface, I can say even class child implements workable interface, and the kind of work child is going to do is going to be different. Okay, I'm not going to say that class child extends father comma mother. Maybe I would say class child extends parents or something, but I wouldn't say that okay, class child is going to extend father comma mother. Okay, so yeah, so that's basic difference between your interface and abstract class. Again, both talk about abstraction, both are trying to solve the problem of maintaining, um, having, basically both are trying to maintain or giving you a way or a mechanism to maintain consistency in your app. Okay, it's trying to interface is trying to solve the multiple inheritance problem. Okay, so as we were talking about your inheritance, eventually we started talking about your polymorphism as well. So let's see how. So basically polymorphism. So when we say poly, that means many. Morph means form. So in many forms. So let's see what is happening here. So I go to employee class and I have certain method which is abstract. Then I go to manager class. I have additional abstract method, and I have, if you see here, I have a give report method which is not abstract, right? Now if I go to my HR manager class, you would see that okay, add team member was abstract, so I was forced to implement. Get salary was abstract, so I was forced to implement. Okay, but if you look at give report method, it was not abstract. But still, what I have done is I had an additional method called as a give report inside my HR manager class. Okay. Now suppose I create an HR manager object saying HR manager HR is equal to new HR manager. Okay. Now I say HR dot give report. So what would happen? HR is an object of HR manager, right? So your Java will try to look for your give report method inside your HR manager. It will find it and it will execute it. Okay. So now what is this override? What is this super dot give report? What is the meaning of super? Imagine that uh, when you say give report, every manager has some common way of reporting it. Okay, so they have to report, so that's why we have some common functionality kept in a manager class. Okay, but apart from that, what every manager is doing, depending on his designation or her designation, there could be some different ways or different kind of work they would be doing, right? So consider that HR manager needs to report to someone, I mean her manager or his manager, but there is some additional functionality that she needs to do apart from what we have defined inside a give report method inside your manager class, right? Now consider that so you are saying that okay, so you want some extra functionality. Now how do you give extra functionality? One way is create a separate method saying with a separate name inside your HR manager class, right? But is that a good approach? So suppose I created a separate method instead of give report inside my HR manager class. Okay, and I'm saying that okay, so as this HR manager has some extra word, I don't want to use the give report method. Instead of that, I want to use a separate new method what I have created here. Now what will happen is tomorrow some other programmer is trying to look into this class or it's trying to use HR manager object. He wouldn't know that okay, the give report method is useless or it's not being used. Instead of that, there is some other method, and what will happen is you will end up with having some incorrect functionality in your application, right? So you are saying that okay, so that means having a separate method with different name is a bad idea, because you still have that give report method which is doing nothing, and you have an additional method, and some other programmer would be unaware of that additional method, and he can just keep using your give report method instead of the new method, and you would have incorrect results in your application. Okay, so I'm saying that okay, I will have a give report method inside my HR manager class. Okay, but now what I want to do is I want to use existing functionality and I want to add some additional functionality on top of it. So that's the reason we have this super.give report. So when you say super.give report, what are we trying to do here is, suppose we say hr.give report. So on a object hr, you say hr.give report, you call give report method. So your control of execution will come to give report method because it will find give report method inside your HR manager class, right? Now it enters inside. Now the moment it enters inside, it finds another method call saying that super.give report. So when you say super.give report, so let's see where it goes. So if you see that super.give report goes to your manager class, that means what has happened over here is you entered give report. Super.give report means call give report method from your super class. That means call give report method from your parent class. Okay, so you the control of execution goes to the parent class, executes whatever is there. Once that execution is over, again it comes back to your HR manager class, where from where you had called super.give report. Now this execution is over. Okay, now whatever you write after your super.give report, that will be executed, right? Now suppose you don't want to execute whatever is there in your common class, so just remove this call to your super.give report. So you're not using any common functionality which is there in your parent class. So it's up to you that if you want to use the common functionality in your parent class or you don't want to use it. Okay, another thing is, it's not necessary that super.give report has to be the first statement. It's just that once you enter give report, wherever you will write it, at that moment it will be executed. You may have some couple of lines before this, couple of lines before, sorry, after this, right? Or you can have super.give report as the last statement in your method. That's, I mean, it's completely up to you that at what point of a time you want to execute program inside your give report from your parent class. Okay, so basically super.give report is just trying to distinguish between your give report in your current class and your parent class. Imagine that if I remove this super dot, what would happen is this just becomes recursive call. See, it has highlighted the same give report. Okay, if I do this and if I do this, see, it's not highlighting the same give report, right? Your idea is smart that it is trying to tell you that, okay, if you don't write super.give report and you just write give report, you are actually making a recursive call. So you enter this method and again it finds call to itself, and this will be a indefinite loop, right? Resulting in your stack overflow exception. So basically, uh, if you see, again I can say that I'm trying to say there are poly, that is many places where my give report is existing, that is my parent class as well as my child class. Okay, and but in different forms, because I can, my original give report has some code and my give report in my child class has some additional code, right? That means my give report exists at multiple places in different forms. This is how I'm achieving polymorphism. So polymorphism has two parts. One is your overriding and another is your overloading. Okay, so what we are looking at is method overriding. Okay, so what we did is we had another copy of existing method from parent class to the child class. So we are trying to override the controls. It's like having additional authority or power to override those controls, and you're saying that, okay, whatever parent class is giving me, I can use all of that, but apart from that I need some additional facilities or additional, I want to write some additional program for some additional functionalities. Okay, so we are using polymorphism here when we are trying to override a method from your parent class to child class. So see, if you don't override the method, you can still use this give report method from your parent class, right? But still you want additional functionality, so you have overridden the method and you're trying to add some existing functionalities. Okay, so this is your give report method which we have overridden, and by making a call to super, we are trying to execute the code even in the parent class as well. Okay, so this was your method overriding. Okay, now let's see, or let's understand what your method overloading is. So polymorphism has two parts: method overriding and method overloading. So we have spoken about, or we have discussed about your method overriding because it's parent child relationship. That's why we are overriding it. Parents had some authorities, but now childs are trying to override those authorities. Okay, so let's see that how do we deal with your uh, method overloading. So let's go to this class called as a say my math class. Okay, so if you look at this particular my math class, I have a method called as a add, and it accepts four parameters and all are integers, right? but I have one more add method, okay, where I'm accepting two parameters. I have another add method where I'm accepting three parameters. I have one more add method, but where I am accepting two parameters, but now this time these two are not integer, these two are float. Okay, and again I have another add method with again two parameters, but my two parameters are now it's neither int nor float, it's double, right? So basically Java allows you to have a method with exact same name inside the same class, okay, but there is a condition that either number of parameters should be different or type of parameter should be different. So if you observe these two add methods, here I have two floats, here I have two doubles. If you observe these two add methods, here I have two floats, but here I have three integers. Okay, if you see here, in both cases they are integers, but here again there are two integers, here there are three integers. Okay, so there is some difference, right? So if I say that, say my math dot say add, and I pass say 2 comma 3, so it will call add method where there are two parameters and both are integers. Okay, then suppose I say okay add, and I say 2 comma 3 comma 4, then it would pick add method with three parameters where all are integers. Suppose I say I have an add method where I say uh, I can say 2.4 comma say 3.4, so I would Java would pick add method with your double parameters, right? So basically you can see here again poly, that is many, you can see add method is present at your many places but in different forms. Different forms, why? Because either your number of parameters are different or your type of parameters are different. Okay, so if you see here three parameters, here are two parameters, here they are integers, here they are float. Again here are two parameters, here both are float, but here both are double, right? So again we are trying to achieve a polymorphism, but the concept is a bit different um, than overriding. So as I said, polymorphism has two parts. One is your method overriding, and you have something called as a method overloading. Okay, so basically if you see what we have covered today is abstraction, we have covered your inheritance, and we have covered polymorphism. Now the last part which is left is your encapsulation, but encapsulation I will continue later, not in this session particularly, because when I'm talking about encapsulation I want to make you understand what package is, what your access modifiers is, so that you can understand encapsulation better. Okay, so for now you can understand, I hope you have understood abstraction, you have understood inheritance, and we spoke about interfaces, and we have spoken about polymorphism. Okay, so that's all about it.